Okay, so that was it for part one. For part two, we're going to take a look at some of the transformations that we can apply to these graphs and to their functions, to the equations of the graphs as well. So what I want you to do, maybe I should make this a little bit easier to see. What I want you to do is use the sliders below to change the values manually for A, B, C, and D. So there's going to be four letters in this transformation, four possible transformations that we could use, that we could do to this graph. And they're going to be represented by these four letters, A, B, C, and D. I want you to change each of them one at a time, and then set it back to either its default value of 1 for A and B, or 0 for C and D. And as you change these things, so here's a slider for A, right? In red is going to be the parent function, just the normal sine of x, the sine function. And then in blue, we have, let's make it a little bit bigger here. In blue, so I want you to play around and try changing these values for A, B, C, and D. So if you change, okay, so small interruption there. Sorry. So yeah. So you can change the value of A by just dragging this slider, and notice what it does. So I kind of want you to play around with this yourselves. And when you change this value of A, it's like changing the value of A in the equation of this transformed sine function. And I want you to play around with them, and then just think about those vocabulary that we kind of went over: amplitude, period, horizontal or phase shift, and vertical shift, and think about what do they change? What does changing A do in terms of those? What does it change on the graph? Does it change the um, the amplitude? Does it change the wavelength or the period? Does it add a vertical shift or a horizontal or phase shift to the graph? All right. So play around with this and just kind of make note of them, of those changes for later. And then on the next screen is a similar kind of graph, but for the cosine function, and the same values A, B, C, and D that can be changed on this transformed cosine function. So in red will be the parent, the normal cosine function. In blue will be the transformed one. And what happens when you change these values? How does the graph change? So just kind of play around with those two screens and make a note of what these things do. How do they change the graph? I'm going to pause. Play around. Spend a few minutes definitely playing around with both of those. Okay, so I'm going to go over here, and hopefully you've done some exploration on your own. I can't do this for you guys. I mean, you need to be doing the discovery and the kind of exploration on your own. But hopefully what you noticed is that by changing the value of A on either the sine or the cosine function, it doesn't matter. It does the same effect. Changing the value of A to a bigger number changes the amplitude of the wave, right? So the default is 1, right? Because think about the sine and cosine function. They both go from +1 to -1. And so 1 is the amplitude. This value of A is 1. But if I change A to, say, 3, then suddenly the amplitude of the wave is 3. So it'll go up to +3 and down to -3. And so if this value in front of the cosine is 3, then that becomes the amplitude. What about B? What did B change? Changing B changes the period or the wavelength of the function. So making B a higher value, say maybe making B equal 3, um, it it makes the period smaller. It makes the period smaller. It makes it shrink, and kind of compresses the wave. And if b is a smaller value, it kind of can spread it out. So let me set this back to 1. What does changing c do? Changing c is this phase shift, this horizontal, or what I'm calling a phase shift. If you want to make it kind of fun, you can press this arrow and have it kind of go through and do this, and it'll like go back and forth using the sliders. All right, normally there's 0 phase shift, 0 horizontal shift. And then D, what does D do? It adds a vertical shift to the graph. And these are the same transformations that we played around with at the very start of this year, because they affect every graph the same way. The interesting ones here are the amplitude and the period, because those are unique to cosine and cosine functions. But this, if you notice where c is, it's at changing x to x minus c, and so c is a horizontal shift, and this d at the end is just a plus d, so it adds a vertical shift. And a is also a we messed around with that at the beginning of the year. It's a scaling of the function, so it increases the amplitude. Okay, so here's a quick check A. I've got a couple quick checks of your understanding of changing these values. Based on what you saw in there, and changing the value of A when the equation changes which of these 4. So go ahead and try that yourself. What does changing A here do? Okay, coming back onto the next screen. Hopefully you noticed changing A changes the amplitude, right? That's what I said. Just I need this to kind of like solidify. You need to kind of remember this stuff. So for example, here's the red graph is the normal sine function. The blue graph is a sine function with a different amplitude. It's 4 times the sine of x, and so it's got an amplitude of 4. And there's a formula you could think of as the amplitude is the absolute value of A. And you might want to write that down somewhere in your notes for later. You will use it again later. So here's an amplitude check. So here's the thing. What's the amplitude of this red graph? See if you can figure that out based on the graph. What is its amplitude? Go ahead and do that, and then I'll move on. Okay, so here's quick check B. What does changing B do to the graph? Which 4 kind of vocabulary words did it change? See if you can figure that out, and then a quick pause. And then on the next slide, hopefully you noticed that changing B changes the period. That's what I said before. So here is in red the regular cosine function, and here in blue is a cosine function with a different period, right? And this is actually the cosine of 4 times x, cosine of 4x. You can see a couple things here. When we add this 4 in front of x inside the cosine function, what that means is that there's actually 4 periods inside where normally there is only 1 period of the cosine. So here's 1 period of the cosine function, right? From 0 to 2 pi. Now we've got 4 cycles inside there. So there's a couple of like formulas we could use for this. So one is that the period of a transformed function is 2 pi. It's normally the period. 2 pi divided by b, because b tells you how many cycles go inside there. So 2 pi divided by b is the new period. Or if we switch things around, the value, if we have a graph of a function, b, the value of b here is 2 pi divided by whatever its period is. So that's another thing to write down somewhere, these 2 formulas. Period is the trickiest part of these transformations, I think. So here's a graph. In red is the normal sine function from 0 to 2 pi. And then in blue there's a transformed sine function. And see if you can figure out what is the period of the blue graph and what is the b? What is the value of b then? See if you can figure that out. Maybe I'll help you out with this one because this one is honestly, it's the trickiest of the 4 transformations. So here, if you notice, there's 2 cycles of sine now, where normally there was 1. So the period, instead of being 2 pi, is half of that. It's just pi. So the period now is equal to pi, which means, maybe I'll just say so. So b is equal to 2 pi divided by the period. 2 pi divided by the period, which is equal, so 2 pi divided by pi. Pi is the period. And so you can simplify this to, if you cancel out the pi's, 2. The value of b is 2. So this would be, the blue graph is this sine of 2x, where the 2 would be inside here. All right, quick check C. What does the changing C do to the graph? Which of the 4 does it change? Go ahead and select your answer. Okay, so hopefully you noticed changing C, this value of x plus or minus something, creates a phase shift, a horizontal shift in the left or right direction. And if you notice, this was the tricky transformation from before, where if it's x minus something, it actually moves to the right by that much. If it's x plus something, it moves to the left by that much. So the phase shift is equal to whatever the value of c is. Like c here is, it's not minus pi over 2, it's because it's normally it's x minus c, so the phase shift here, it was pi over 2. The blue graph has been shifted that much to the right. And that's another formula you might want to write down for later. Okay, phase shift check. In the red, you've got the graph of the sine function. In the blue, it's phase shifted to the left. So what is the value of c here, or what is the transformed function? See if you can figure that out on your own. And hopefully you notice that c is, let's see, you can click on these points. The blue graph is shifted to the left by pi over 2, which means that the phase shift is to the left by pi over 2. So c equals plus pi over 2. In other words, it would be, it's the graph of f of x equals sine of x plus pi over 2. All right, and last but not least, quick check D. What is the changing the value of D due to the graph? Which of these 4 does it change? Go ahead and put your answer in. Pause it real quick. Okay, so hopefully you notice changing the value of D causes a vertical shift in the function. So if we do cosine of x in red, and then cosine of x plus 3 outside the function, outside the parentheses, that means D is equal to 3. It just shifts the function up by 3. It shifts everything up, including what I like to think about as the midline. The midline is normally 0, right? So you could think this is plus 0 at the end. Now the middle of the graph is at 3. And so the highest value goes as 4, and the lowest value goes as 2, because we haven't changed the amplitude. So vertical shift is equal to the value of D. That's an important formula to maybe write down for later. Here's a vertical shift check. In red, we've got the sine function. And then in blue, we've got another sine function, but it's been shifted vertically. So what is the value of d? What is the vertical shift? Or what is the function? We're kind of taking this in steps. Go ahead and see if you can figure that out. All right. So hopefully you noticed that this is shifted down by 2. So the vertical shift is down 2. So d is equal to minus 2. In other words, this is the graph of sine of x minus 2 at the end. And finally, I've got a few challenge problems for you here. Write the equation for this graph. So as you do this, and this is going to take practice, we're going to practice more next week. This is going to take practice, and I'm sure you'll do that more in pre-calc next year. But here's a graph. Think about these questions as you try to figure out what's the equation. Are these key points one cycle of sine or one cycle of cosine? What's the amplitude? That would be the value of A, right? What's the period, the length of the cycle? How do you find the value of B based on the period? If you remember, there's that formula, B is equal to 2 pi divided by the period. What is the phase shift or the value of C? Is there any phase shift left or right from the normal? And is there any vertical shift up or down from the normal? And if you can figure those out, you can write an equation for this graph. And if you hit submit, it should graph whatever equation you wrote. So if you wrote f of x equals, I don't know, if you just thought it was the cosine, right? Sine or cosine of x. And you hit submit, it should graph what you write in there, and you'll see if it matches up with these points. And if it doesn't, then you might have to change one of these 4 values, A, B, C, or D. Go ahead, try that on your own. I've actually put 3 challenges in here. So there's this one, this is the second one, and then this is the third one. They're all the same, and you can submit any function and see if you're right. So try it out, try to figure out, see if you can understand these transformations a little bit better. And then that is the end of the video. And if you need help with this, feel free to, email me, send me a private comment in Classroom. I'm here to help you guys. I know we've only got a couple weeks left, but I mean, I'm always available. And I think for the last week of school, we've got technically June 9th is the last day of lessons in online distance learning. After that, you've got like a week of just make stuff up if you missed anything. So that last week, June 9th, is a Tuesday. I'm not gonna send out any work, any lessons. Instead, I was hoping that we could do a like kind of large Zoom chat kind of thing, all together at the same time. See how many people we can get online, and I'll send something out about that to figure out what time works best for most people. So send me your reflection about this lesson at the end. Let me know how it went. I hope you all have a great week, and hang in there. Summer's almost here. Bye, guys.